Let's have another example, this time for independent samples naman. A professor at a large community college wanted to determine whether there's a difference in the means of final exam scores between students who took his statistics course online and the students who took his face-to-face statistics class. He believed that the mean of the final exam scores for the online class would be lower than that of the face-to-face. Was the professor correct? Again, itong mga questions na to galing to sa OpenStax na high school probability. You can check the book sa ating Google Classroom. Okay, so we have here 30 scores from the group of online class and then 30 scores from the face-to-face class. Gawin natin para malinaw mamaya, first population natin yung online, tapos second population yung face-to-face class. I've already computed the values or the mean, the standard deviation, and 30 lang naman yun, for both the online and face-to-face classes. So, pwede nyo i-encode lang ulit sa calculator nyo and then compute for the mean and then the standard deviation. So we have here. And then, we're now ready to formulate our null and alternative hypotheses. Okay, by the way, this is independent because yung grupo ng mga nasa online ay ibang grupo nung nasa face-to-face. So, bale, meron tayong, ang population natin, dun sa una will be the students who are taking online classes. Then, we randomly select 30 from them. And then, dun sa kabila naman, population natin, yung mga nagtitake ng face-to-face, and then we randomly selected 30 students from them. Our null hypothesis, actually, alternative yung una yung magagawa dito, no? The exam scores daw nung online class ay lower than that of the face-to-face class. So for example, yung mean, for example, ang mean natin for online class is mu sub 1 at ang mean natin for face-to-face class is mu sub 2. If the exam scores of those online class is lower than that of the face-to-face class, and yung claim ng professor, then that will become mu sub 1 is less than mu sub 2. So this will be our alternative hypothesis. Yung sa null hypothesis natin, pwedeng equal lang yung gamitin natin. So we'll have the mean final exam scores of the online class is equal to the mean final exam scores of the face-to-face class. So that's basically mu sub 1 equals mu sub 2. For the alternative, the mean final exam scores of the online class is less than the mean final score of the face-to-face class. So we'll have this one. Mu sub 1 is less than mu sub 2. And we're now ready to get the appropriate test procedure. Let's get again this table. Ang ating alternative hypothesis ay less than. So, dito tayo. Yan, sa row na yon. Tapos, ang n natin masyadong madami, no? 30 na nga dun sa isang grupo, tapos 30 ulit sa isang grupo. So, in this case, your n here, which is equivalent to n sub 1 plus n sub 2, is greater than 25. So we'll be using this column. And then we're going to compare the computed value of t sa negative z alpha. Okay, and then we will be using one-tailed independent samples t-test. Alpha equals 0.05. And we're going to reject the null hypothesis if the computed value of t is less than the tabular value of z. Otherwise, we fail to reject the null hypothesis. Okay, we're going to compute now. Okay, we'll now be selecting the appropriate test statistic for our case. Pero na-box ko na dito na we'll be using the equal population variance, assuming equal population variance. Ang pagde-decide natin ito, when you go to research 1 ba research 2, you will have a test, either using Levene's test or an F-test to decide if the variances are statistically different or not. Pero as a rule of thumb, as a rule of thumb, you can actually just make quick comparison. If the standard deviation of the bigger standard deviation divided by the smaller standard deviation is less than 2, then you can safely assume that the population variances are equal. Okay, so for now, since mamaya makita natin medyo halos parehas yung standard deviations nung dalawang grupo natin, ng online class tsaka nung face-to-face class. So, we'll be using this formula, assuming equal population variance. Okay, ito yung sinasabi ko kanina. We can compare the standard deviations. The ratio of the standard deviation of the online class, which is 16.9, as to face-to-face, which is 11.7, is definitely less than 2. So we can safely assume that the population variance are equal. Okay, so in this case, unahin natin computein yung pooled variance. So ito, pooled variance. Oops. So for the pooled variance, substitute lang natin yung mga values. You have this one, think 30 yun. Take note, standard deviation to ha, hindi to variance pa. So we still have to square them. Pero kung variance na yung kinuha nyo, pa-plug nyo lang yan. And then, we have 211.7341. And we can now compute for the t, the test statistic. So basically, substitute lang natin. Ito, itong d sub 0, 0 ulit to because of our alternative hypotheses. Mu sub 1 equals mu sub 2. Therefore, the difference, hypothesized difference, so that's 0. Your pooled variance is 211, 1 over 30 plus 1 over 30. And therefore, the value of t is negative 3.2286. Okay. So we're done with computing the pooled variance and then the test statistic. Now, we're now going to determine the z alpha. Well, yung z alpha natin ay z ng 0.05. Tama? 1 tilde, no? 0.05. Alam na natin to. This is 1.645. So, negative yung ating pagko-comparean. So, what's our decision? I-reject daw natin yon if the computed value of t is less than z alpha, negative z alpha. And definitely, negative 3.2 is less than negative 1.645. So, definitely, we're going to reject the null hypothesis. Our conclusion now is, ano yung claim nga ng teacher? Ang claim niya ay the final score, exam scores of the online class is lower. Okay? So definitely, ang ating decision is in favor of the alternative hypothesis. So, therefore, our final verdict conclusion is that at 5% level of significance, we have sufficient evidence to conclude that the professor's claim is correct, that the mean final exam scores of the online class is lower than that of the mean final score of the face-to-face class.